Welcome in Electronics for Scientists of the summer semester 2019-2020. In this video I'm going to talk about bipolar junction transistor BJT, band structure of BJT, transistor biasing, small signal amplifier model, and finally we can take exercises and discussion. BJT can be defined as semiconductor device that has three different regions. Two are positive semiconductor types and one is negative, or two are negative semiconductor types and one is positive. The BJT is usually called bipolar junction device because it has two different junctions. As we can see in the structure of BJT here, collector, base, emitter. The junction between emitter base is referred to as BE, and the junction between base and collector is referred to as BC. The BJT has three pins: emitter, base, and collector. And here we see different types of transistor. Here, E, B, C. NPN transistor. This figure shows the structure of NPN transistor. It has three regions, as we have already said: emitter, base, and collector. The emitter is heavily doped n-type semiconductor, and the collector is also n-type semiconductor, but the number of electrons in collector is less than that of emitter. In between, there's a thin layer, which is p-type semiconductor, is called base. As we see in this figure, the collector is bigger than the emitter. This will help the collector to collect most of electrons that injected from emitter to collector. Additionally, we can see here between emitter and base there is a junction. This is PN junction diode, and here this is the anode and this cathode. Also between base and collector there is N junction, PN junction, and here the anode and cathode. We see here this is the representation of the PNP transistor. Between base and emitter there is PN junction diode, and here the anode, cathode. Also between base and collector there is a PN junction diode, and this is the anode and this cathode. Here this is the electronic symbol of a transistor. This is an electronic circuit, and we see here this is the arrow exit from the emitter. That means this is NPN transistor. Here emitter, base, and collector. Now we take PNP transistor. The structure of PNP transistor is shown in this figure. We see here three regions: emitter, base, and collector. Both the emitter and collector are p-type semiconductors, whereas the base is n-type semiconductor. We can see here the collector is bigger than the emitter. This will help collector to collect most of holes that injected from emitter to the collector. We see also that between emitter and base there is a PN junction, and here the emitter is anode and the base is cathode. Also between collector and base there is a PN junction diode. The collector is anode and the base is the cathode. And this is representative of PNP transistor. Here the base is cathode, the emitter is anode, and the collector is anode also. The electronic symbol of the PNP transistor is shown in this figure. We see here the arrow is entered to the transistor, whereas we see here in the NPN transistor the arrow was exited from the transistor. Here we see the band structure of NPN and PNP transistor. In the first one, here we see this is the emitter N-type and the collector N-type, and the base is the P-type. In the PNP transistor, we see here the P-type emitter to the N-type base, and then to the P-type collector. Basic operation of a BJT. There are three types of voltages in the transistor, regardless NPN transistor or PNP transistor. Between emitter and base, there is V sub EB. Between base and collector, V sub CB. Between collector and emitter, V sub CE. There are also three types of currents. I sub E, the emitter current, I sub B, the base current, and I sub C, the collector current. The difference between the NPN transistor and PNP transistor is the direction of these currents. We see here an NPN transistor, the IE exits from the transistor. Here the IE enters the transistor. I sub C and I sub B enter to the transistor in NPNP, and here I sub C and IP exits from the transistor in PNP. In the second case, the transistor is connected to external voltages. EB junction should be forward biased and CB junction should be reverse biased. As you can see in this figure, NPN transistor, the input circuit is the EB junction and the output circuit is the BC junction. Here the emitter, which is N-type, is connected to the negative terminal. That means it is in the forward bias. Whereas here the collector, which is also N-type, is connected to the positive terminal. That means it is in reverse bias. In the first junction, EB junction, here the applied voltage, which is referred to as V sub EE, the external of the applied voltage will reduce the internal field of the junction itself, and this causes the depletion layer or space charge regions to be reduced. Now, what about the Fermi level in the conduction band and the valence band? The situation of CP junction is inverted. The internal electric field direction is from right to left hand, and the external electric field is also from right to the left hand. This electric field will enhance the internal electric field, and the depletion layer width or the space charge region width will be increased. When the transistor is connected to external voltages, this is called in active mode, and the band structure is shown in this figure. Here the Fermi levels will be splitted. We see here in the emitter, which is NP type, here the Fermi level goes up. In the base, the P type, the Fermi level goes down, and here also in the collector the Fermi level goes up. The built-in voltage will be subtracted from the applied voltage in the EP junction, and in the BC junction, here the built-in voltage will be added to the applied voltage. The BJT can be connected in three methods. The first one is called common base. In the common base, the base is common between emitter and collector. The input circuit here, B junction, is connected in forward bias, and the BC is connected to the reverse bias. Two voltages here in the input circuit, V sub EB between emitter and base, and between base and collector, V sub CB. B refers to common base. The emitter collector here is equal to the collector current plus the base current. Because base current is so small, the collector current is approximately equal to the emitter current. The second method is common emitter. Here the emitter, as shown in this figure, is common between base and collector. The input circuit is emitter base, and the output circuit is the emitter collector junction. The input junction is connected in forward bias, whereas the output is connected in the reverse biased. We have two voltages in the input here, VB sub E. E means the common emitter, and the output voltage is V sub E. The emitter collector is also equal to collector current plus base current.